Good afternoon, Dr. Francis.
Yeah, hello, good afternoon, everybody. I believe you can hear me. Oh,
Yeah, good
Good
afternoon. How are you?
afternoon.
Explain this.
Afternoon. Jade, how are
I
you?
am a simulator pilot. I understand what goes on in the air.
wow. Okay, see what's going on. Hello, good afternoon, everybody. I believe you can hear me.
Good afternoon.
Yeah, good afternoon. How are you?
I understand the worry.
Okay, all right. So something wrong somewhere. Microphone access on and okay. All right. Okay. See. All right.
On that,
Hello.
and it watch.
I believe you can hear me.
Good afternoon, sir.
Good afternoon, sir.
Yeah. So can we start?
Yes, so the
Yeah,
thing
so
is
the
that
thing is that
he can hear us, but we can't hear him. So initially we could hear him and he couldn't hear us. But now I think he's talking, but we can't hear him. So I'm just we're chatting. I'm talking to him about it.
Maybe you can disconnect and join back with his audio.
All
All right.
Okay, sir, I'll tell him that.
right. Okay. Okay. Good afternoon, everybody. I believe you can hear me at the moment.
Yeah, afternoon.
The Bible
Okay.
says it.
I didn't get what you just said.
I was saying good afternoon. Greeting
And
you.
my
Okay.
parents,
Yeah.
only
Welcome.
spiritual perish. You will perish in this life.
Okay. All right. Okay. So let me get to share my screen. All right. So today we'll just get to here. You can see the settings to share my screen. Okay. Okay. All right. Okay. All right. This can go away. All right. I think this is going to problem. I'll launch the session out. So I'm just waiting to get some settings up on my system. It was taking time. Okay. Okay. Yeah, hello, can you see my screen at the moment?
Yeah, can see your screen now.
Okay. All right. Okay. Environment. Okay. Okay. I'm gonna put Anaconda. Anaconda is far superior to this. So while I'm doing that, today we'll be talking about Python. I believe almost everyone here is used to programming in Python or has just started programming in Python. So I think recently when me and Nonya spoke, he said almost everybody here has not been programming in Python for some time. The majority of the class is that is a beginner class. I believe the assessment of the class is very correct.
Yes.
Yes.
Okay. All right. So while I am trying to do this, so I'm trying to launch, I think during the class, we want to talk about using a different programming environment. So the programming environment that I'm trying to launch here is the Jupyter Lab on the browser. So in the browser, so there is also another alternative to use the Jupyter Lab. So you can use the Jupyter Lab from an environment called Jupyter Desktop. So the Jupyter Desktop is similar to what you will see on the Jupyter Lab. However, it's not going to use your browser. It's not browser dependent. So depending on how far you've programmed, how your programs appear, sometimes it will be browser dependent. So this Jupyter desktop itself it does almost everything. So it has an inbuilt browser in itself. So that is what makes it very different. And sometimes your browser environment may change from depending on the operating system you're using. So that's one of those things. What's going on here? Okay, all right. Oh, all right. Okay, let's just give me 2 minutes. I'll need to reload all these things. And then cancel offsets. Okay, right.
Hello.
Yeah, hello, good afternoon, everybody.
Good
Yeah, we can
afternoon.
hear you now. Yeah.
All right, okay. All right, sometimes technology can be very, very annoying. While it's very good, it can be very annoying. All right, so yeah. Hello, good afternoon, everybody. I believe you can hear me at the moment.
Yes, we can. Good afternoon.
All right, okay. Sometimes, as in technology is the way it is. So I think we waste a lot of time trying to get in together. So let me start with, I believe, just by a show of hand, how many of us here have programmed before or have done anything with programming or just by a show of hand? Hello?
Yeah, we can hear you.
And so by a show of hand, just by showing whether you programmed before or not, let me just want to get an idea of those who will call or just get to get their understanding of what is going on so that we don't get them lost, who have programmed before, who have written any computer programmed, be it in Excel, Python, Java, VBA, any language at all. Nobody? All right. Okay. So what I'll start with is this. Today we'll be doing NumPy, and I believe we've covered the parts of what NumPy is. Can by definition, if that is how to say it, what you think NumPy is. Hello, anybody? Can anybody attempt that? What do you think NumPy is? Hello?
Yeah, we're here.
Okay, so by definition, what do you think NumPy is? Just, I know you may not have used NumPy before, but what do you think is going to be like?
I heard, if I can attempt, I heard it stands for numerical Python. That's
Okay.
it's used for numerical Python.
Okay, all right.
Yeah,
So
that's what I think too. It
okay.
functions. It also functions for working in domain of linear algebra, Fourier transform, and matrices.
Okay, so now, as what we'll do today, we won't go very deep into what Python is essentially, so that you don't what NumPy is essentially, but it's just to give you an idea of how to use it with some toy data and toy variables. Then you see how some things called methods and some things called routines. So these are programming language lingos. So then the data structure, essentially, I believe everybody here has used Excel before. Is that correct?
Yeah.
Okay. So in Excel, like, what is the highest number of rows as the maximum amount of rows, a maximum amount of columns you can store in Excel?
I think it's about 1 million.
Okay. 1 million rows, and how many thousands or millions of columns?
About 16,000 or so.
About 16,000 thereabout. So that roughly gives you about 16 billion thereabout of elements in the sheets. And when you get to that level in Excel, it will be very, very difficult for you to open it. Sometimes it might take you 5, 10, 15, 20 minutes. You might have to make coffee to come back, and your data is still loading. So why do we have to bother ourselves? Excel is fine. We can do everything we want to do in Excel. Why do we have to bother ourselves using NumPy or Python? Why do we have to bother ourselves? As in, we need to do that because, one, if you're in the banking industry, you're analyzing banking transactions. Banking transactions may be millions, billions of transactions, and you don't want to do that in Excel. And Excel data, sometimes depending on how far you've gone, it may be very difficult to reproduce. What you've done may not be auditable, except you have it in a VBA script. So we said is numerical Python. Yes. So I think that gives us an idea around the fact that what NumPy will always do. So there is something called integer float. Has anybody heard of integer or float before? Hello?
Yes.
Okay. So what does it mean?
Oh, they are numbers. Integers are whole numbers, and floats are numeric. What's it called? Decimals, basically. They are both numbers.
Okay, decimals. Okay, I know. As you shouldn't do that. So the unit of data structure in Excel is a table, while in Python, so in any programming language, there are multiple. There are lists, there are dictionaries, there are tuples, all those ones. There are ways in which you can store data in, but in NumPy generally, NumPy generally deals with numerical data because it's easy. And then that brings us to the point of typing, or as what we call dynamic typing and non-dynamic typing. So who has written any program in JavaScript or VBA before?
No.
No. Okay. So just like, so if you are going to, if we are writing in JavaScript, in Python we say x is, let's say x is 25, x is 45. So, but in Python this way, we've written x is 45. X can be integer, it can be float, it can be anything, it can be an object. So in Python, Python is dynamically typed. That's why you can assign variables without explicitly describing what it is. If it is in a VBA script, now we are writing a VBA or JavaScript, we have to say, let's say we are doing a VBA script, we have to deem that x is integer. But in Python, I believe you can see my screen. You can see what I'm writing on the screen.
Yes.
Okay. All right. So if you don't understand anything, please feel free to stop me at any time. So this as int. So this kind of system of pre-specifying y of what our x should be is what we call static typing. So you've stated it is very rigid. It cannot be changed. So that's static typing. But in Python, you just assign your variable. X is 45. It can be int, it can be anything whatsoever. So that is why it is called a dynamically typed language. But those ones are generally what's it called. Therefore, some of us who are interested in deeper details of computer programming. Then, so let's say now, I believe we all know how to import variables, import libraries into our work. Hello, can you hear me? Hello, everybody.
Yes, we can hear you.
Okay, I believe we all know how to import a library into our work. So a library itself is a pre-written program, pre-written set of programs that we use to enhance what we're already doing. You get. So this time around, like Pandas is about 11,000 lines of code. But at each point in time, I can't remember exactly how many lines of codes is in NumPy at the moment. Each time you want to use it, you can't just bring in 11,000 lines of code into your work. Though that's what you're doing technically, but you can bring in those 11,000 lines. So in Python, there are different ways that we do it in different languages. But in Python, import NumPy as NP. Okay. I believe you can see what I'm doing. Hello?
Yes, we can.
Yes, we can.
Okay. So what I have done now, is I've imported the libraries, so I need to run them. But what I have done here is, in instance, I can actually stop this and say import NumPy. Import NumPy, and it is sufficient. But because this is, we're trying to save how much time we need to type. And then we'll put what we call an aliasing as NP. If you like, depending on your standards in your code system, you can import your NumPy as NMP. As NMP, and import it as NY, as NY, depending. So this part is the alias part of it. But by convention, we import NumPy as NP. All right. So let's get to that part. Okay. So then, why do we need, in Python, we know there is a system called lists. There is a data structure that is called lists. Okay. So take, for instance, let's say the list is this, is 1, 2, 3, 4. Okay. All right. You notice I'm running each of all these lines one by one. As I am doing that, yeah, I'm loading that into the memory. So that's the benefit and essence of using the Jupyter Notebook or Jupyter Lab. Then, okay. So, but we can also do the same list in NumPy as we'll get there. So, all right, okay. Okay, so how do we do an array? We store data in NumPy as arrays, and these arrays are generally in themselves lists. They can be lists depending on how they are compounded, how they are modeled up together to give different dimensions. So in Python, this is a Python list. Okay, so all right. So, but in NumPy, we'll have something like, let's say our A is np dot. That's how we'll np dot array. So this part of this np is the NumPy dot array. This array I'm calling on the NumPy is called a method. It's called a method. This method, all those things have been specified in the programming of NumPy. All right, okay. So then I've defined this. Just 1, 2, 3, 4, 5, 6. So this is I've written an array now. I believe you are following. If you have any question, please don't hesitate to stop me. Hello, everybody.
Yeah, well, with you.
Yes, we can hear you.
Okay, all right. So this is an array now. So there are so many methods, so many things we can check about this array. But now, let me say a dot. How many dimension is this array? So this is a one-dimension array. And when we say an array is one dimension, it means it's a vector. So as a one DM array is a vector. So let's do the same thing. Yeah.
Sorry, I wanted to ask a question. The a dot end, is that what checks for the kind of array it is?
Yes, it checks for the as you can
The
see,
dimensions.
number of dimensions. So as the array grows bigger, so as in I'm going to be doing so that it grows bigger one by one, so that we understand what the arrays and dimension, and I'll be introducing what they are called specifically.
Okay.
All right. So here, this array, this array now is a vector. Is a vector. Now, then let's redo the array again. Let's redo the array. Then we'll run our okay. Okay. All right. Okay. All right. So let's do a dot ndim again. You can see that it has changed. Can you see that?
Yes, but it didn't give us any value. How many dimensions is it?
This is 2. Just check. Okay.
Okay. It didn't show before. Yeah.
Okay. So the number of dimension has changed to be 2. Okay. So then by convention, okay, let's get to array number 3. So let's change it to okay. All right. Okay. There's something wrong here. All right. All right. Okay. So let's just stop at that first. Let's just stop at the 2 dimension first. So we've done 1 dimension and 2 dimension. And then, so I want to show you something about the 2 dimensions. This first part, the convention in which it is being used, this first part is like a row in Excel. This second part is like the second row. Okay. So then that gets us to okay. So let's say Take, for instance, I put this. Okay. Okay. A dots and then dimensions. So this is a 3-dimension. Why is this a 3-dimension? Anyway, let's just leave this. So as we've done this now, then let's restart. Okay, let's restart and do that. So we've done this. Okay. So here, all right, it wasn't imported. Please, if you are confused, just let me know. Escape. All right. So now a dot shape. So let's see what is the shape of this array. As you can see, this is. Hello, can you see?
Yes.
Okay, it looks like it's confusing. All right, so let me pick. So let's reassign those variables. Let's make this A. Let's make this B. Let's make this C. Let's make this C. So, you know, we've used NDIM to know the number of dimensions of the array. So we can also use a method in Python, in pandas, in NumPy rather, to check how is it shaped. Is it the like length times breadth? How essentially how many elements are in those arrays? So we've done this for that. Then we move down to B. Let's go to B. Let's go B dot shape. Okay. So I'm getting this error. Why do you think I'm getting this error?
Traceback, notation colors, shape.
Okay. So
You didn't run B.
I did not run B. So that is the as error messages in this way is your friend. Just look down and anytime you see this error message, ignore everything that is on top. Just go down to the last part of the error message. So you will see exactly, it will give you an idea what exactly is going wrong there. So you can go back and fix it. Error message is your friend as when you are programming. Is not okay. So did you get that? All right. Okay. All right. So we can also call another method. So let's say that we don't know what is in A. So we know the kind of data that is in A. As if we want to do the type of data that is in A, as we can use this. A data type is giving us this. All right. Please, if you're not following, just let me know.
What's the difference between just using A dot type? Why didn't you just use A dot type? Why do we have to use
D type? Okay, this is a specified method in what's it called, in NumPy. But in Python, as you see, this lists, this Python list here, yes, as in you can call a dot type on list. Okay, so let's say type int type list. So as you can see, this is list. Okay, so that is what we'll get. So typically you cannot call the type method on what's it called, on a NumPy array. Can you see? As in, we'll get an error on it. So typically, if you want to check the type, okay. All right. So let's say that we've done this. Then we can actually convert these types into floats or anything. So let's say we want to reconvert this A type to floats. Let's say A. mp.array B type. All right. Can you see what I did there? Hello, can you see what I did?
Yes.
So as what did I try to achieve? Okay, you know before. Let me start over. Let me start over. You know before our type, you can see our A. Our type is int. You get it? But I want to change this type to float. So how do I do that? Okay. So as what I just did was this. So, and I specified that the D type, the data type, should be float. But by default, the data type that goes into your NumPy array is integer. So, but by default, so you can also change it to float. We can change it to, so with this, we can change it to object. We can change it to anything.
Okay.
So you say that I have changed now. So I can also change it to object if I want. So object means that it should be string. I believe we all know what string means.
Yes.
Okay, all right. Then, so we've gotten to, then let's say we've gotten to this part. Let's play with a little bit. Let's play with a little bit. Let's say now we want to do this is A. You know, in Python lists here, we can subset or index strings, index, list, column, anything whatsoever. Okay. Right. So let's say this list, you know, which you can say lists. Lists, you can say that gets the 1. So I want to get 1 here. How do I get the 1 here in Python?
0.
0. Okay. So, but in some programming languages, you start with 1. So in Python, Python is a 0-based indexing programming language. So in some programming languages, you have to start with 1. Okay. Now I want to get that, so we'll put 0 there. Okay. Let's put 0. Okay. So this thing we've called here, this indexing we've called here, you can also apply the same thing to this array. Let's say A. Okay. So as we can do the same thing. So how do I get? I want to index. I want to pick 3 and 4. So how do I get that?
Three and 4, 0. That's 2, 3.
Okay. Index 2, 3. Okay.
Yes.
All right. It did not work. Why? Why? Okay. So
what's the error message?
too many indices for a
One
one-dimensional
dimensional,
array.
but 2 were indexed.
I think
Yes.
let's try to separate the so 2 in one bracket, 3 in one bracket.
Oh,
Okay. Let's see. Okay. We are still getting the same error.
object is not substituted.
So it means that you cannot index the index that you have inside there. So you can only do this for a 2-dimensional array. All right. Let's keep that for later, as in I'll teach you how to do that later. So let's say I want to pick number 6. There are multiple ways as in to pick that. So how do I do it? How do I do
-1.
-1. Okay, so what about if I don't want minus in it? So how do I do it?
5.
That's 5.
5. Okay. All right. So I think we're able to index that properly.
Sorry, for that one that we got error message before, we could do A brackets 2:3.
Okay. All right. So what is there is, so, you know, it is similar to Excel. A 2:. It's just similar to Excel. You know, if you've used Excel before, I believe you've seen something like this before. You see, this is, you know, we want to get 3 and 4. So you can do this. So it's similar to what you see in Excel. You know, in Excel, you will see colon, is F something, then you see colon. So this is how you index, you pick those things. So as what he has done is You are saying pick between this and this.
Oh, okay.
As you get the logic now.
Yeah.
So I can extend it to, let's say, 5. It's just the same way you do in Excel. It's similar to Excel generally. So it's just between this and this. Okay. All right. So when we get to 2-dimensional arrays, I believe it will make more sense. All right. Okay, that's that. So let's get to now. This is we know we have 1, 2, 3, 4, 5, 6 variables here in this A. So, but let's say you've gotten this, but you want to split it into 2 rows and 2 columns. Then we can say that let's say, okay, escape. Let's do into 2 rows. You can say A dot reshape. So we've reshaped it into 3 by 2. So, okay, 3 by 2. So we've gotten this shape. But now we now have this small thing here, object. Do you know the reason why we have this?
Because the type wasn't specified.
No, as in the type, by default.
Okay,
The
it's
type,
object.
no, by default, the type in NumPy is an integer. But you know, we've come here to specify that it should be
Float.
object. So now I want to specify as float. So we'll come back here and redo it as float. So integer, float, or as in all of them work together with this. So let's say, let's get a dot d type now. You can see that because we specify float here, is now a float. So, but if we remove this, we remove the d type, we'll go back to our default. So this, as in for you to reshape an array, the row by column, your old row, let's say your old row is OR, and your
New row.
old column, or your old column is OC. So your old row times old column must be equal to your new row times your new column. You get? So that's how you, as in you do that to reform it. So such that sometimes you may have, this is for a 2-dimensional array. But if you have a 3-dimensional array, so the same thing happens. So all the dimensions here, so all the things you get in the shape must be equal, as when you multiply them. Say for instance, now we want to reshape this to 3, 5. As we are going to have an error. Can you see? Cannot reshape array into size 6 into shape 3, 5. All right. Okay. All right. So let's get to our 2-dimensional arrays. Let's get to 2-dimensional array. Then before we go to 2-dimensional array, let's say for instance, we want to sum, we have our lists to be 1, 2, 3, 4, 5, 6. So it's, you know that 6. You know that you can actually sum this. in Python ordinarily. So why do we need NumPy? NumPy is we are putting overload on what we are supposed to do. Okay. All right. So let's say that we wanted to compare. So this is a dummy. As this is a dummy, but we'll just compare this now quickly. Let's move our np.array. The necessity for us to use this because is apart from being very fast. When your type is specified already, just like what I was talking about here, when we say if you are doing VBA, dim x as dim x as integer. Yeah. So this is in a VBA, not in Python, please. That you don't forget. As this is in VBA. What this does for you, it tells the program that anywhere you see X, don't waste space to create space, because here the space requirement, the memory allocation for this, I don't know if this is making sense to, it's not supposed to be, is some basic types of computer science anyway. So the memory allocation for this is very, very high. So it takes a lot of time for the processor to interpret the language and do what you want it to do. So now we're going to do some small comparison. Let's say, okay, let's just make this to 10, 7, 8, 8, 10. Okay, so then we'll draw a list. So I just want to show you some small comparison on why, though this is, what was it called? Is dummy may not show the difference properly. Okay. Let's do a comparison. Let's do a comparison now. So we said as we have a list here that is 1 to 10, and we have an array that is 1 to 10 here. So we want to perform an operation in such a way that we want to see a comparison between the two. All right. Okay. All right. So let's do some. Let's do some of the list. So, okay. Okay. All right. Is the list is too small to show the time difference. The list is actually too small to show the time difference. But generally, the NP array is always very, very fast. So now I've done a sum of this list. So how do I do a sum on an array? I do the same sum as this. As in sum A, fine, works. There is also an alternative way, A dot sum. So the same way you can call this. So in what I've showed you here, I believe you are following what I'm doing.
Yes.
Okay, as in what I've showed you here, this sum, this is a routine, while this is a method. This is inbuilt system as an inbuilt routine inside Python, while this is a method from the NumPy library itself. So let's say that we want to do some other things. Let's say we want to do some other things now. Let's see. We can say a dot mean. We can also find the mean. We can also find median. All right. Okay. All right. As no attribute median. Wow. Okay. Then std. All right. Okay. What's going on? All right. So, okay. All right. So let's go to our two-dimension arrays. Please, if you know, okay. All right, let's go to our two-dimension arrays from here. Please, if you have any difficulty, if you're not following, please let me know. We said the shape of our B is 2 by 6. All right, so let's convert this array now to, let's do some operations on it. Okay. Okay. So we'll start with what our B is. So we said our B is this array. So let's say we want to sum this part of this array. How do we do that? Hello? Okay. We said we have b dot sum. As we can call sum on it. But we want one part of this. This is doing everything. So how do we get one part of the B to actually help us do something? Hello?
How do we get what? Sorry. How do we get one part? Is that what you said?
Yes, no, this is a 2D array.
Yes.
We have a part, we have another part.
Yes.
But how do we sum, so that also we can sum one part and not sum the other part?
Yes.
No, this is the first row, this is the second row. So how do we sum such a way that we sum only the rows alone? Initially we called b.sum.
Yes.
b.sum summed everything.
Yes.
But now we want only one part. Is there a way we can do that?
If can we index it in the sum of in the bracket? Probably 0.
Okay.
That work?
All right. Let's do b.index. Zero. All right. So then we can call sum on it.
You can and put sum in dot sum. Okay.
All right. But in NumPy, there is an inbuilt way as in to actually do it. So we can say that B dot sum, then you specify, because if you have like 300 rows,
Yes.
as you cannot count, this is row 21, row 22, row 23, is a very hard thing to do. So what we'll do is you specify your axis equals 1. So the difference between the axis, okay, let's just run this first and let me show you. Can you see?
Okay.
So if we are to have done this, we have to use a for loop or while loop or any of the loops to get this number. So now we specify this. So this returns an array for us. So we can even continue our analysis further. But now
But
we
this way,
want,
it sums both of them. Now we wanted to sum only one of the
yes, as in
one. We wanted to sum only one row now, but now it sums the two rows for us.
as it sums only one row. This is 1, and it sums this other one again.
Yes,
And
it sums the two rows for us.
yes, and if you want to specify 1, what you just do is you just index it out. Just index out. So we'll get the same value.
Oh, okay.
Yes.
So the axis, what does that parameter?
Okay. So this axis, there is axis 1, where axis is equal to 1 means is the row. Then where axis equals 0, it means is a column. So how you remember it is this. For that, I remember it this way. If there is zero gravity, it means the thing will hang.
Yeah.
Is that correct? So it means it means it's column. So that's how. So now we've summed all these columns. We've summed it by column wise.
Oh, I see. Oh, when you do axis equals to 0, it sums by column.
It sums by column. If you do axis is 1, it sums by row and returns everything in an array. Okay. So we did a conversion here. We converted our, what's it called? Our A, which is a, then our A, which is a vector, we converted it, okay? So our B is this. So, we converted A to a 2D array. You know that we can also convert a 2D array to 1D array if we are interested in doing that. So how do we do that? Okay. All right. So what we'll do, if you want to convert any dimension array to a vector, I'm trying to use vector and dimension array interchangeable so that I don't, before I introduce the proper name is called. So this two-dimensional array, the two-dimensional array we have here, the technical name is a matrix. And for people who are engineers or people who have done further maths in secondary school, you remember we used to do matrices. So this it is. So the essence of the matrix is somebody defined the NumPy array as working with linear algebra. So is that part of linear algebra that the matrices actually work on? The matrices, the multi-dimensional arrays actually work on. So then let's call on this. So as we've shaped it before. So now, okay, let's go to this. Okay. All right. All right. Okay. So that gets us to that point. So then as we've gotten an array like this. Can we create something similar to B by filling it with 1 throughout? Maybe you've collected a data, then this is a data of some groups, but you want to fill all of them with 1, 1, 1, something like that in your analysis. So how do you do that? Okay. So let's say that npm dot once like B.
Was like
B. No, this B is, you remember that B, this is our B.
yes, it's a
You can
two.
create a two-dimensional array. We want to create
Yes.
something similar to B, but we want to fill it with a
So that's what is that a function? The ones like
Yes. If you look at if you are using the Jupyter Notebook, you will see all these, there are different colors. Yeah, those things are called syntactic highlighting. So it highlights the syntax so that you know where all those functions are coming from. These colors, you see that this color and this color are similar.
yes.
Yes. So it means that it's coming from a method that you called from NumPy or any other program that you've imported. But when you look at sum, I think you look at sum. We did list. Look at list.
Yeah, it's
Look at
green in
print.
color. Yeah,
There has
they're
to be
green in color.
So those things are from Python itself.
Oh, okay. Oh, so the blue is from like the library.
Yes, it's from the library. It's from the library or any other function you've defined. All right. Okay. All right. So let's get to, okay. Now, as we want to reshape this B, let's reshape B. No, okay. Let's assign this one to Y. Assign this one to Y. And I want to turn this one to a one-dimensional array. Y dot of flatten. Okay. So you want to make it flat. So I'm getting this error. Why do you think I'm getting this error?
Can't see the error yet though. It's not showing.
Okay. Okay. It seems there is a lag. Okay.
Okay, yeah. You didn't
So
run
why
the Y. You defined Y, but did you run it?
Okay. So just look at each time you get this kind of error that something is not defined.
Yes.
Just look for the Y. You can see here. You see this color is different.
Yeah. Yes.
So it means that it has not been run.
Yes.
So you just run that, and then we'll redo everything. So we've transformed our 2D array So our 2D, so from now, I'll be using matrix, vector, tensor, so that as in we will be in the same way, so that we'll get used to the terms as we go in. So this is, we've converted the matrix now to a vector. So we can do as many things as we like with it. So there are so many things you can actually do with this. All right. So from this now, okay. From this, what else can we do in this? Let's see. Okay. So let's say that one, we want to do. So we have two arrays. You know, if you've done SQL, if you've used SQL before, you can actually put, if you also use pandas. No, you can use pandas. Maybe for some reasons you don't want to use pandas. As you want to join two matrices together. Let's say our first matrix is. I want you to take notes. B dot array. Of this. So when you open this, then you now open this other new one. Let's say 25, 36, 49, 9. Five, 78. So I'm just making up numbers, please. It's not.
Yeah, but I was going to ask, how can we determine? I think the amount of brackets is a bit confusing when we are trying to create the matrices.
So yeah, so that is what I'm trying to. So you see that we say np dot array. See, this array is a, what's it called? That array is a method. So in that array, this bracket first. So there is a bracket first.
Yes.
And there is another bracket that specifies your list. That's for a two-dimensional array.
Okay.
As if you're doing a two-dimensional array. If you are increasing the bracket more, then it means you are specifying an higher order dimension. Say for instance, now I'll show you. Say for instance, we have 25, 35, 45, 90, 78. So let's call the dimension on it. All right. Okay. Okay. What's going on? All right.
Other housing attributes.
Okay. All right. So let's just remove this. All right. So then q.dim. So what is going on? Why am I having this error?
I'm thinking the brackets are too much.
No, it's not. You know the you know the you know when I was telling you that we need a specified number of dimensions. This
Yes.
I'm calling a method has no attributes that is not defined in the NumPy array, in the NumPy library. So what you're saying is it has no attributes. So it means it's not defined in NumPy. Okay.
The space in front of the queue, does that affect anything when
No,
you're defining?
no, no,
Okay.
it doesn't. As in, the space only matters if there are other codes.
Okay.
You know, Python is indenting based. So
Okay.
the problem will only happen if we have this
And
copied
something
from,
underneath it. Okay.
and there's something below or above it.
Okay. Okay.
Okay. So, but here, so I've called dim, q.dim. So I'm getting this error as no attribute dim. So what am I supposed to? I want to get the number of dimension.
I think
Of this.
N is missing. N dim. Q
Okay.
N dim.
All right.
Number of dimension.
So I'm also getting this. What do you get?
Object is not callable.
Why is
Okay.
is not callable is this, because I specified this. So the
Okay.
reason why, as in the reason why this is this, as in, let me tell you the reason why. So when you call a method
Yes.
on a variable, so if you are putting this, it means that it must take arguments.
Arguments. Okay.
Yes, it must take arguments in it. Sometimes, depending on how the program is written, these arguments may remain default, as they may specify as default.
As okay. Like when you use flatten, there was no argument in it. It was just the brackets
Yes,
alone.
it was just a bracket alone. So the person who has written it has specified some default arguments that goes into it. So,
Okay.
but this method does not take arguments. So, all right. So I just want to show you something. Have you seen what happened?
Okay. It said it was a 3-dimension. Is it because of the 3 brackets?
Yes. So is the brackets that actually that determines the as you can see. So if I remove this bracket now, our ending becomes 2.
Oh, okay.
You get? All right. So
No, but I'm still going to ask again. If it's already 2-dimension, that means it's no longer a vector, right? Where is?
Yeah.
But all I can see is just one row. What would be the second row that makes it 2-dimension? Because
so
25, 35, 45, 78 are within one row already.
Yes, it's one row, but the other row is not defined. So there's supposed to be a space for a row. It's just like in Excel when you have table. You know, you
Oh,
fill
so it's like blank.
number 1,
Okay.
but there is space for number.
Oh, okay, I get.
But you've only filled one row. So the other
Okay.
row is empty. So this part is the part that is empty. Okay. So
Okay. And you can still take a value in the
is equivalent to writing this. So what I just did is equivalent to writing this. So Okay, so it's going to throw an error. It's going to throw an error. So this, can you see my cursor?
Yes.
Okay, so maybe let's make it wider. And see this, you know, this is, if you put anything as within this, now I put a comma, I put another thing, that's a 2D, as in a 2D array, which is a matrix.
Yes.
Okay, then I open my brackets here. Put my bracket here. You know, technically there is a space here. There is a space
Yes.
here. Okay, let's put something there so that you will see. So there is a space there. Okay. All right. So why am I getting this error? Because there is no because there is no common. Okay. All right. All right. Let's leave that for now. Let's leave that for now. I don't want to confuse you by moving to higher dimensions. Let's go to 2.5, 2.8. Well, for most of your work, you'll be doing 2D, except you get to machine learning when you when you're doing classification, supervised and unsupervised learning. That's when you need to access the higher dimensions. So yeah, that's when you get to machine. That's when you need to get this. Okay, let's put this. Okay, we're still having 2 dimensions. So meaning that there is a space here as we need to fill. Okay. All right. All right. Okay. So why am I getting this error?
Because the rows is not equal to the column. I think number
Okay.
of rows is not equal to the number of columns.
All right. That's that. Okay. So let's just do that. Then let's say U is another thing. This is see. All right. So now what you want to do is to put them together. As in to put them all on top of each other. And what I mean by all on top of each other, I'm trying to introduce the language in which we're going to use that. What I mean is that I want us to stack both of them. So how can we stack U and this? You know, we can stack it horizontally or vertically.
Yes.
Okay. If you agree with me, okay. All right. Okay. So how do we stack it if we want to? How?
That's all of it into one array, right?
Yes, as in let's stack it into, we'll stack it, but it will remain in the same dimension. That's what I mean by stacking. As we are putting it together, but it will remain in the same
dimensions.
In the same number of dimension. You know, you can stack vector matrices such a way that it gives you a higher dimension. But this time around, I want us to do in the same dimension, such that the enddim will still remain the same. You know, the Q, say U dot enddim is 2. So I want us to join both of them together such a way that we
You'll
still
still be
have
two
the same.
dimensions.
We
Can we use
still have the
reshape?
same
Oh no, reshape will change
the shape already. So there is a method, there is a method in NumPy. Is simple as let's say MP dots. If you are going to put them on each other, you know, this is row 1, row 2 here, and in Q,
row 1, row 2 as well.
row 1, row 2. So, okay, so let's stack Q and U together. So MP dots vertically, so that this one will be row 1, row 2, row 3, row 4. You get. So MP dot V stack, MP dot V stack. Of V stack. So that gives us Q and P. That gives us our array. Okay. P is not defined. So why am I getting P is not defined?
You didn't. P, you've not defined P. P is a new variable that hasn't
Okay.
been.
All right. All right. So let's change it to U. Okay.
Say it takes one positional argument, what 2 are given.
2 are given. Okay. All right. So do you understand what happened there?
No. You say it
All
only
right.
takes one argument, but we gave 2 arguments, which is Q and U.
So have you seen what happened here? As in, I've corrected the error. So do you see what happened?
Yes. Row 1, row 2,
Row 3.
and row 3, row 4.
So as what up is in the way this VStack is programmed, this is the only argument. Okay.
Okay.
Let me show you what happened. So I said that as when we call a method, there are arguments that goes into it. So here, the argument, you know, we said Q and U, Q,
Yes.
comma U. But we run that, it said that there were what? Need
It
one,
takes
one
but
argument.
we gave 2.
Or we gave 2. So in this, so depending on how, in this, the only argument it takes is this. So Q and U becomes one argument.
Oh, so we merge them together to become one in the brackets.
Yes. Yes.
Okay.
As you say that. So let's do. So the same way we have VStack, we also have HStack. It's just like VLOOKUP, HLOOKUP in Excel.
Okay. But this will merge in rows, right? As opposed to.
Yes.
This will merge in columns, rather.
As in, it will merge the columns together. You know, this is, this is rows. The VLOOKUP is just like append.
Yeah.
In Excel. I don't know if you've done, if you just like append in Excel. Okay. So what it does is just pile them on top of each other, one by one. Why the HStack what it does is this one now, if we are doing, let's say we are analyzing proper data, it's just like pandas data, PD data frame, as when you append data frame, such a way that you specify the axis. So in a different way. So what this has done is that this number is not, this is you said Q and U.
Yeah.
This is first row, second row. So we'll still have this in that first row. We'll still have this
Yeah.
in the second row.
Yes.
So it's the same thing that has happened here.
Oh.
Vertically,
So it merges rows.
yes, but
It merges the
here,
2 rows together.
2 rows together.
Oh, so it
So,
just makes them one row,
yes.
one row.
One row, one
Okay.
row. Okay.
Yes.
Then, here, then I want to introduce the concept of broadcasting. Let's introduce the concept of broadcasting. All right. Okay. So, in English, when you say broadcasting, what does it mean in itself? In English, what does it mean?
Announce.
Okay. Okay. You want to announce, you want to disseminate an information or something.
Yeah.
Oh, okay. So the concept of broadcasting is that, that here in our array, we've done something like, we've done some standard deviation and all those stuff. So I think I've introduced it a little bit. So we can do the same thing here. Let's say now you want to square all of what is here, what is in this U. How do we achieve that? We want to square everything.
I have to use for loop.
Okay, but let's say there are about 1 million rows. How do you do that? Are you gonna use 1 million rows? As
No.
you go and make coffee, come back, you are still doing for loop. So as this is the same way that you. So similarly, so what you can do is in NumPy, you can do the same thing here. So in how do we indicate square in Python?
Double asterisk.
Double asterisk. Is there any other way you can do it?
Except there's a function for it. I'm not sure.
Yeah.
That you can call.
So is
Or you can create your own function rather.
and create your own function. So you can see this. I think it's power U, 2. Okay. So do you see this color? So this color shows you that this is an inbuilt Python function.
Function. Yeah.
It's an inbuilt function that we've made it square. But you can also do it in a different way. U star 2. You can see that the answers is not different. So the essence of using the NumPy is that the types are already pre-specified, and the way it is done is what is used in writing the program is not in its Python, is a lower level language, such a way that the interaction is very fast, and it doesn't use plenty of memory. So as we've done that, so what else can we do? Okay, let's say now we've joined these two parts. As we've joined these two parts, as we've turned this to this, and we want to take this middle part. So how do we do it out? We only need this middle part.
Would index it? Can't we index it?
Yes, as in is the same indexing. Okay, let's say that now we've joined this. Let's assign let's say stack. Let's say this is HST is as a, this is we've horizontally stacked this now, but then we now said, okay, you've done this, but we need to split it again. As in, how do we split it back?
How do we split it back?
We've joined it, but and you don't want to. So how do we split it back? So in NumPy there is also a what's it called? A method was for us to split it back. So it is called, now, do you want to split it horizontally or vertically? Okay.
Okay.
Let's split horizontally. Now let's start with splitting horizontally, then we'll split vertical next. So HST dot H splits. Okay, all right. Okay, let's call it MP dot HST. MP dot H splits. Let's do a split. So we'll call in the what we want to split, HST. So where do we want to split it? So you know that we use what's it called? Okay, let's iterate over it first. Let's iterate over it so that you have an intuitive idea around it. So let's start from 2. Let's start from 2. Let's start from 2. Okay.
So it broke into two columns.
Yes.
All right, I made it 4 rows.
What I just did is this. You see this?
Yes.
It's the same thing as
How?
you.
Oh, okay. The same thing with the VStack where you placed the 4.
Yes. Okay. Let's see.
But I can see that there are 2 arrays now.
Yeah, as in that's what you will get. You have to split it into 2.
Okay.
So look at your U. Can you see? I don't know if I've not. Just hope I've not ended up confusing you. Just look at this. Is it similar to this?
Yes, it is.
All right. So where we want to cut, in that splitting, we want to cut. Let's say we've gotten to 4.
Oh, so it's 4 different arrays.
Yeah. But if you want to split it by that part, so you can also specify this. So what have we done? 1, 2, 3, 4. We just separated it into 2.
No, but you'd use 4 this time around compared to when you used 2 earlier, and you still got the same.
Yeah, this 2 is 2, what's it called? To split it into 2.
Yes.
So here, as in this 4, what 4 does is specifies the position, this 4 in brackets specifies the position in which you want to break this.
Oh, at every 4th value.
At this point, from this point where this cursor is.
Yes.
So if you want to do it at 5, you can do it this way. You can see that this first one is longer than the second one.
Yes. Okay,
So-
and it starts from 25 to 25 as well.
So
And then breaks the, oh, okay, I see.
it's 6. So you can also do it at 7. And see, 1, 2, 3, 4, 5, 6, 7, 8. So here, the concept of 0 indexing does not work.
Yeah.
As you get. So I want 7, the first part, then the other part is what it is. You get. So we have 2 arrays here now that we've just split into 2. Okay, so the same thing is happens in vertical splitting. Let's just say Control C, Control V. Okay, all right. What happened there? All right. So it's the same. You're calling the same thing. The only thing you change is the V part of the splitting. Well, now, okay, let's run this code and see what happens.
V splits. It specifies the shape and the type.
Yeah. So what happened? So it means that the first array is full.
The second is full as well.
No, second array is empty.
Oh, yes, that's true.
Second array is empty because why? Because we said 7. And this HST is only 2 rows. We say you should split from row 7. That's what is here. Okay, let me say row 3. Let me say row 2.
Vertical splits. It's saying you split at 7.
This is row 2 now. There is 0. Then from row 1, you see that this array will be filled up. As you can see.
No, sorry, I'm not getting this part of it.
Okay. As in just all right. So what I've said is I took HST. Our HST is this array.
Yes.
Is that true? So
Yes.
we said we want to split the array vertically.
Yes.
We want to split the array vertically from row 1. If you say row 1, if you say row, okay, let me, so you can have the proper intuition around it. So this is row 0. What has row 0 done? And what it did was the first part is empty. Is an
The
empty
first
array.
row.
Yes, the first row is an empty array.
Yes.
Is shape 0, 8. The second part is this. Or we will now specify this 1. You know that the, okay, all right. So let's, let me do the HST dot ending. You know that HST is a two-dimensional array.
Yes.
Then HST dot shape is 2 rows, 8 columns.
Yes.
Okay. So now I want to split it vertically. Then I specify that it should start from
Row 1.
columns, as in column 0. That means above here. 0 indexing does not work.
Yes.
That's what I want to demonstrate. 0 indexing does not. So you start column 0. It means that it's above the array itself. So what it means is that the first one will be empty. The second one will be full. Then if you put it at 1, both of them will be filled.
Yes.
So if you start at 3, 3 now is bigger than the row. So 3 is bigger than the row. So it means that you have full array at the top. At the bottom, it will be empty. Do you get the logic now? Hello, can you hear me? If you're confused at any point, please let me know. Hello, can you hear me?
Yeah, I can hear you now. Sorry.
Okay. So, did you get what I just did?
No, I dropped off for a minute. A call came in.
Okay. So
the 3 there, is that speaking to column or the row? Because I know it's a two by
okay.
2
All
by
right.
8. That's 2
So
rows to 8 columns.
if you use, okay,
For vsplit, is it
if it's,
a row or a column that's
so
indexed?
if you use vsplit, this will become row. If you
Okay.
turn this to hsplit, this will become column.
Okay.
Okay, I see. So it's the same thing here. All right. So please, as in, if you have any questions, please let me know. It looks like okay. So as we've been able to done splitting. Then let's say we want to insert a row or column inside this row. So how do we do that?
Want to insert what?
As we want to insert a row to the HST. No, is like V stacking. We can do V stacking. You can do V stacking, but there is also a different way. In Excel, we have what we call append. So that's what I want to introduce to you. Apart from V stacking, you can also do such a way that you can put together two rows, two different arrays without using V stacking, and you also do an append on it. Okay. All right. So let's say that this. Hello, I believe you are following me.
Sorry, I missed up what you. Yeah, I'm okay.
Okay, as in which parts don't you understand before we start going into the very, very complex ones?
I think I got everything open to the V splits and V and H splits.
Okay, so the H split
But
is this.
I think I'm the only one left on the call right now. I usually the class lasts from 1 to 2. I think it's already 1:30.
Okay, wow. As in,
Yeah.
I wasn't. I'm already engrossed. I wasn't really okay. All right.
Yeah.
So maybe we'll continue from this point until
Yes.
later part.
Yes.
All right.
But by the way, sorry, I don't know. I was going to ask, are you um are you an alumni of LBS?
Yes.
Oh, okay. What set?
MBA 17 class.
MBA 17. Oh, okay. I did the full. I MMBA too.
All right.
Yes. Is there any way I can get your contact? Probably I can just reach out to you. I'm trying to go full time into this data analytics thing, so I'm really, really interested in it, or rather invested in it as well.
All right. As in, it will be very, very fine. So, do you want my phone number or my email? Which one?
Your phone number will be great. I think that. I'm listening. Let me just save the number.
Okay. All right. 00625766120. So I've sent it to you.
080. Okay, you sent it to me.
Yes, I've sent it to you, Graham.
Okay, the name is Marvelous, so I'll probably give you a call and see how it goes from. Yes.
All right. Okay. So that
Wait,
is.
I can't. Is it via chat you sent it?
Yes.
It's not showing here yet.
All right. So this is a direct message to you. So I've sent it to you. So you've seen it?
No, not yet. I don't know. Your network has been a bit so. Most of the time, it was lagging even while you were. I wasn't seeing some messages on time or responses.
Okay. All right. So 006.
Okay.
257.
6257.
6120.
6120. Okay. Okay.
All right.
Yes.
Okay.
All right. Thank you. I'll reach out to you one-on-one.
Okay. All right.
All right. Yeah. Thank you. Cheers. Are you going to be around next week?
I don't know yet, but I'll tell
Okay.
Nonye. I'll tell Nonye.
Okay. Okay. All right.
All right.
Yeah. Thank you.
Okay. All right.